Hello everyone. Tonight we start talking about lateral and surface area of prisms and cylinders. Before we do that, we should define what a prism is and what a cylinder is. So a prism is any three-dimensional solid with two congruent ends, which we're going to call bases. So in this case, on the formula sheet, your ends would be, or your bases would be triangles, and they're congruent. And then they're connected by rectangular sides, also known as lateral faces. This is another example of a prism. This is a rectangular prism, whereas this is a triangular prism because the bases are rectangles. Because in a prism, all of the lateral faces are rectangles, and in a rectangular prism, everything is a rectangle, any opposite sides, so any ends of the prism can be the bases, and any of the other sides can be considered the lateral sides or the faces. So to find the lateral area of a prism, what that means is we're going to be finding the area of all of the lateral faces or all the sides, everything excluding the tops and the bottoms. The formula given on the formula sheet is HP, where H stands for the height of the prism, or in other words, the distance from base to base, because what you'll see sometimes is that a prism might be drawn like this, so it's sitting on its side instead of sitting on one of its bases. So the height might not always be up and down. Sometimes it could be horizontal, but just keep in mind that the height of the prism is defined as the distance from one base to the other. And the P stands for perimeter of the base of the prism. So you're going to find the perimeter, or the distance, all the way around the base. When we are defining lateral area of a rectangular prism, again, because any two of the opposite rectangles, so like this one over here, for example, and this one back here, could be the bases, or the bottom and the top, or the front and the back. There's no defined formula for lateral area of a rectangular prism. Just take the area or take the height of the lateral face and then find the perimeter of whatever it is we're defining as the base to find the lateral area there. Surface area is the area of everything, so all of the lateral faces, including the bases. So the surface area of any prism, except for a rectangular prism, is basically the lateral area plus the area of the top and the bottom, or the area of the bases of the prism. So a capital letter B is going to stand for the area of the base of a 3D figure. So in this case, our bases are triangles, so we would need to use the area formula for a triangle in this case and multiply it times 2 because we have two of them, a top and a bottom base. The surface area is given here as 2 times the length and the width, plus 2 times the length times the height, plus 2 times the width times the height. So that one's fairly simple. So again, lateral area is the area just of the sides or the lateral faces, whereas surface area includes the lateral area plus the area of both bases, top and bottom. All right, a prism is just one of the 3D figures we're going to talk about today. The other one is the cylinder. And a cylinder is, I think we all know what a cylinder is. It's a 3D solid with two congruent circles, sometimes ovals, but we'll never see those in this year's geometry. And the sides are a curve all the way around. So the lateral area is given to you on your formula sheet where, of course, we know 2 and pi. R is the radius of your cylinder, and H again stands for the height or the distance between your bases, just like it did in a prism. And the surface area is essentially the lateral area plus the area of your two bases. And in this case, our bases are circles, so we're going to use our pi r squared formula and then double it because we have two circles. So it's the lateral area plus the area of the tops and the bottoms. And make sure you jot down your 3 questions, and I'll see you guys in class.